Hey guys and gals, today we're going to be looking at absolute value inequalities. So we've done inequalities, we've solved absolute value equations. Now we're going to do absolute value inequalities. So let's just first kind of think about these. So if I have the absolute value of x is greater than or equal to 7, well, I know anything that's 7 or bigger will solve that for sure. I'm going to go ahead and plot that. Let's see, here's 7 over here. It's got equality on it, so I'm going to make a solid dot. Oops. 7, not 5. There we go. And I'm going to shade everything greater than that. So that way, I'm actually going to make that a little bit smaller. There we go. That'll work. Now, what else could work? X is greater than or equal to 7, but it's not just x, it's the absolute value of x. So if I have really big negative numbers like -10, the absolute value of -10 is +10. So that's going to work. So let's think about it. I mean, 7, -7, absolute value of -7 is 7. So I'm going to grab that right there. And if I do anything smaller than that, that'll also work for this particular problem. Okay, so just thinking about it, you can kind of see what it actually has to be. Okay, so that's that one. How do you write that in notation? Well, it's just a compound inequality. Negative infinity to -7, and it does include it, union, including 7 to infinity. All right, sure. Let's think about this one. Okay, x is less than or equal to 4. It's absolute value, though. So let's just start with x is less than or equal to 4. What's that look like? It's got this. And I know I got to go that way, right? Yeah, smaller. So I got to go something like this. What's that absolute value going to do? It's got to be small. The absolute value has to be smaller than 4. So it's got to be, it's in between some numbers. Well, if I plug in a 0, that's still going to work. If I plug in a -1, yeah. Okay, how about -2? Yeah, what about -10? -10 doesn't work, so I can't go on forever. I plug in -4 though, that works. And it's 4, so if I plug in anything smaller than -4, that'll be the absolute value would be bigger than 4, so that ain't gonna work. Right here, it's gotta be the 4. It's got that equality on it, so it does include it. So this will be my solution right here, everything between -4 and 4. All right, not too terrible. Okay. I don't like having to think so much. Guess what? You don't have to think so much. You just have to be able to read. Yes, that's hard for some of you, but try it. So let's look at what this actually says. The absolute value of x is greater than or equal to 7. Here's how I want you to read that. So let's look at this symbol. Whenever we're dealing with absolute value, read the symbol as great or. Yeah, like that. So if I have a greater than symbol, it's going to split it up. It's going to be an or. It's going to be an or compound inequality like this. If I got this one, that's a less than. There you go. Whenever we have this symbol, less than or less than or equal to, either one, it's going to create an and, a sandwich. We're going to have something that looks like this. So this symbol right here, the inequality symbol, tells us what kind of answer we should have with these absolute values. So this is going to look something like this. And this is just going to look something like that. However, let's think about some particular cases. What if I say absolute value of x is less than, I don't know, -5? That can't happen. I mean, it's absolute value. How's your absolute value going to be negative, much less smaller than a negative number? Ain't happening. There's no solution here. All right. So the less than, it might be no solution on there. What if I just change that? What if it was, instead of less than, it was greater than -5? Well, it don't matter what you plug in for x, that's going to be true. Absolute value is always positive. This would be all real numbers. So this would be an empty number line if we had to graph it, and there would be nothing on your interval notation. This would have the entire number line, so it just looks something like, I'm going to do this in a second. It would look like that for your answer here. Doesn't look like that here. And your interval notation would be negative infinity to positive infinity. All right, so those are two special cases. And if you think about it, less than 0 is not going to work. Greater than 0 is always, well, greater than 0 is interesting. Greater than or equal to 0 is all real numbers. Okay, but greater than any negative number is all real numbers. Moving on. Let's do a couple examples. I got 4 of them here. So let's try one. Let's just do it. First and foremost, read. What is this? It's a great or. So I'm going to be splitting it up. So I'm going to take, what does absolute value do again? Let's see. Oh yeah, set up my 2 cases. So I know either this is true, and I'm not going to do the shortcut right yet. I know this is either this is greater than or equal to 1, or, and it can either be this or the negative of this, right? That's what absolute value does. It just makes everything the positive or whatever it is. So this, negative this thing, or this thing is greater than or equal to 1. Well, just like with absolute value equations, we got a shortcut. I've got to divide by this negative. What happens when we divide by a negative? You change the direction of your inequality symbol. All right. I divided by negative, so that's going to be less than or equal to. That way you can see we are dividing by a negative. That changes the direction of our inequality symbol, and that makes that a -1. So here's the shortcut. The inside part's either greater than or equal to this, or less than or equal to the negative of it. Okay? For and, well, I think we'll do next one after that. One of those is going to and. We'll get there. So now you just solve them. You got 2 inequalities, just solve them. It's a compound inequality. That's what we've been doing. You got a fraction, multiply by your LCD. Or any CV, really. So that's 3 times -5 plus 3 times k over 3 greater than or equal to 3 times 1. That's going to cancel with that. That's -15 plus k greater than or equal to 3. Add 15 to both sides. K is greater than or equal to 18. Now, we checked absolute value equations whenever we were, well, we checked absolute value equations. We checked for extraneous roots. It wouldn't hurt to check here. Let's see what happens. If I plug in 18, 18 divided by 3, that's 6. -5 plus 6 is 1. So yeah, that's going to be 1. That's true. And if I plug in anything bigger than 18, it's going to be bigger than 1. So yeah, we're good. You don't have to check these, but you can. It makes you feel better. Don't forget we got that or going on. Subtract 5 from both sides. No, what am I going to do? LCD. Could I subtract 5 first? Sure. There's a million ways you could solve this problem. Not literally, just quite a few. 3 times 5 plus 3 times k over 3. That's equal to 3 times -1. Now, yes, some students will be more fluent and be like, why would you get rid of the fraction at the end? I'm just going to multiply with 3. Sure, whatever you do is fine. Just most of you aren't fluent with your arithmetic, so let's get rid of those fractions. That's less than equal to negative 3, and that's no fault of your own. It's just apparently arithmetic's not important to learn anymore. I don't know. They don't make you memorize stuff. All right, subtract 15 from both sides, and k is less than or equal to negative 18. Okay. You can check that again if you really want to, but I'm not going to. You're good. Yeah, you're good. It's an or. Yeah, let me check that. Hang on. Okay, guys, it took me a minute, but I see what happened. If we go back, copy my problem down wrong right here. It's negative 5. Terribly sorry. That should be a negative right there. That's going to change all these 5s to negatives. That's going to change this to plus 15. And that's going to make a heck of a lot more sense in my head. Whenever I saw that negative 18, I was like, that's not right, because I knew, I mean, if I plug in 0 here, it still works. It had to be something bigger than that. So just 12. Okay. Now, let's check it, because you might drop something off a problem like I just did. 12 over 3 is 4. Negative 1 plus 4 is negative 1. Absolute value of that is 1. Okay, that's better. That's anything less than that. So if I plug in something smaller than that, it's going to be even less than 1. So plug in 0, it's still going to work. It's going to be negative 5. Absolute value of negative 5 is 5. That's good. We're good. Sorry. Apologize. It's an or. So let me stick these on there. I've got a 12 and an 18. I'll stick 12 right there. I'll stick 18 over there. Both are included. So I'll put solid dots on both. I'm greater than or equal to 18, so I'm going to go that way. Less than or equal to 12, I'm going to go that way. Boom. Right interval notation. Negative infinity to 12 inclusive. Union 18 to infinity. And we don't include infinities ever. So after that little pickup right there, we're good. Make sure you copy your problem correctly. Okay, next. Let's try this one, and let's not mess up this time. So again, it's an absolute value, so the first thing you do is isolate it. That hasn't changed. Always isolate your absolute value first. Now, I saw in some of your quizzes, instead of subtracting from both sides of your equation or inequality, you subtracted 3 here, and then you went in here and subtracted 3. No. You subtract from both sides of the equation or the inequality, either one you got. This is inside the absolute value. You can't do anything with that. Don't do that. Oh. Check and make sure you're subtracting from both sides of your equation or inequality in this case. You're not messing with the absolute value, you're isolating it. It shouldn't change. When they do stuff, don't just drop them off. Now it's isolated. Now let me read it. That says absolute value of blah is less than. So an and problem is what's going on here. Remember we had those 2 ways of writing an and? Yeah, we did, didn't we? So we could say that 8a plus 10 is less than 22. And this is not how I like to write it, by the way. 8a plus 10. We divided by a negative 1, so we're going to flip that. We are going to enunciate and change that to negative 22. I like making a sandwich out of it. It's just a lot more efficient to me. Instead of solving 2 problems, I just solve 1. So stick this into a sandwich. Negative 22 less than 8a plus 10 less than 8a, right, wait, I did that, 22. So you just take this, put the negative there, put the positive there, and you make sure you have less than symbols. That goes in the middle. So you make a sandwich out of it. If you're more comfortable solving 2 problems separately, that's on you, whatever. I am going to check the work, but either way you do it's fine by me. Solve for a, in this case, negative 32 less than 8a less than 12 u fractions. Divide by 8, divide by 8, divide by 8, negative 4 less than a less than that they both got a 4 in them. You can use a calculator if you really want to. You probably should. 3 halves though. That's 1.5. If you put it as a mixed number, 1.5. That's right there between 1 and 2. So I'll stick negative 4 over here. And you know what? You can just do this, 3 halves. All right, okay. 4, 5, 6, 3, 2, 3, 2, 1, 0, 1, 2. So yeah, that's lines there, do I? Count by 2s. That's not. Whatever. If this were a 1 and that were a 2, you'd put it right here in the middle. So let's do that. So these aren't evenly spaced. Let's just go with that. They're open. And it's sandwiched between it. All right, just make sure it makes sense. Which, as long as you're checking at the beginning, not doing all this extra work, it'll be fine. Can you have a number that's between negative 4 and 3 halves? Yeah, you can. 0 works just fine. 0's bigger than negative 4, and 0's less than 3 halves, so we're good. That's what it look like whenever you AND. Whenever you have a less than after you isolate it first. Negative infinity. Oh wait, no we don't, do we? No. Negative 4 to 3 halves. Just put a fraction. No decimal place. Don't include it. Next. All right, let's isolate this thing. Let's go less than, right? Oh, wait, we don't know. It's not isolated. So isolated, we're going to divide both sides by negative 10. We have absolute value of 2r minus 1 divided by a negative, so change the direction. 6. So that's why you want to isolate it first before you try and figure out what's going on, because it can change on you. So now it's actually great. Oh, I have 2 problems, and I split them up. 2r minus 1 greater than or equal to 6, or 2r minus 1 less than or equal to negative 6. Again, absolute value, either this thing or negative this thing is greater than or equal to 6. It's negative this thing, just divide by some negative, and you'll just flip that and change that to negative. Here's the shortcut, just remember it. You don't have to remember why, just remember it, and you're good. So yeah, if you check here, make sure it's possible first. Like make sure, this is negative 6, your answer would automatically be all real numbers. You'd be done, don't do any work. But if you don't do that, whenever you go to graph it, the lines will like overlap. You're like, oh, it's all real numbers. So it'll still work, even if you do all the work. But check here, make sure it makes sense. All right, let's solve these things. Oh, main fractions. 2r greater than or equal to 7 r divided by 2. 2 divided by 2 R is greater than or equal to 7/2. Did not flip because I did not divide by a negative. Add 1, add 1, 2R, terrible R, less than or equal to -5, divide by 2. That's negative, so I gotta flip it, right? Wrong. We didn't divide by negative. We're dividing by +2. We don't flip. No flipping. R less than or equal to -5/2. Boom. Graph it. This one's on the left, that one's on the right. I'm just marking these on here. I'll call that -5/2. I'll call this 7/2. Does it really matter? No, as long as this one's on the left and that one's on the right, because smaller numbers go over here, and negative's definitely smaller than positive. It's an or. Okay. Let's do this one. Well, they both include them. Both include solid dots. Solid dots. R is bigger than this thing from a shade to the right. Everything bigger than that. And it's less than this thing from a shade to the left. And then I'm going to write my notation just as I read it. We're in America, we read left to right. We're not in America. Most countries do read left to right. We read left to right in math, so just go with that. Some random European person decides to check on my chain. And it does include it. We're going to union that. 7/2 to infinity. I don't think I actually watches these videos. All right, that's interval notation. We're good. Yeah, one more. We can do one more. Let's see. We got to do multiple steps. It's a left. No, don't care what it is right now. Isolate it first. Add 9. Add 9. 4. Absolute value of 9 minus 3n is less than 84. Divide through by 4. A +4. Don't be go flipping on me. Don't be go flipping. Yeah, that's definitely grammatically correct. Absolute value, that's an n. No. Yeah. 9 minus 3n is less than 21. Use calculator for second arithmetic. Now we have our absolute value isolated. Look at it. What is it? It's a less than, and. So make a sandwich or substitute problems. Because really this is 2 problems, but it's shorter to write and easier, more compact. No steps. I like it. You don't do it that way. Don't do it. Subtract 9. Subtract 9. Oh, yeah, subtract 9 again. We got 3 sides of our inequality here. -30 less than -3n less than, let's see, that's, oh, yeah, use a calculator, that's a 12. Use a calculator. And last thing you need to do right here, almost last thing, is divide through by this -3. That's going to be 10. And oh, wait, I divided by a negative, better flip that around. And flip that around, -4. This is not incorrect, but it's weird. Look at it. We got the bigger thing on the left side. We don't like that. Flip everything around. So start with the -4. says -4 is less than n, and n's got to be bigger than -4, so we can do this. Whenever we write these sandwiches, we like them with less than symbols at the end. So if they have greater than symbols, just write it backwards. These two statements are the same, but this is standard form. Like 4/8 is the same as a half, but we like a half better because it's standard form. Let me grab this thing and move it down. Hey, put it down. All right, I'm gonna stick a -4 right there. I'm gonna stick a 10 over here. And it makes sense. I can have numbers that are bigger than -4 and less than 10. Like 0 works. I always use 0 because it's easy to think about. Use any number. 5 would work. Whatever. I do not include these endpoints. Just everything in between them. So that's -4, 10, close parentheses. They're open circles, so you have parentheses and not brackets. Yay, done. Yeah, that's it. If you like this video, no, I don't care if you like or subscribe, whatever, doesn't matter to me. Yeah, questions, ask on Google Classroom or in class if you're there. That's it, bye.